Hello everyone and welcome to our webinar today. My name's Graham Turner. I'm broadcasting from Asiga head office in Sydney, Australia. Thank you to everyone who's joined today. This webinar will go through what the return on investment looks like for an Asiga 3D printer and touch on the Max UV and the Pro 4K 80, the two systems that are specifically presented to the dental sector. And we have a special guest with us today in Minh Tran. I'm sure Minh really rarely needs an introduction. I'm sure many are familiar with who Minh is. He's very well known across the digital dental world, and he's a key speaker for a number of companies. He works at a big dental laboratory in Canada, and he's also the founder and owner of Dental Tech Tips that reviews lots of dental technology. So Minh, welcome.
Thanks, Graham.
So I'll just shortly hand over to Minh to take control of my screen and the webinar, and I'll go backstage. But whilst Minh is presenting, if you have any questions for Minh or myself, then please use the Q&A section. You can see the feature in the Zoom settings. Just send any questions in that you may have, and we will aim to answer those at the end of the webinar. We'll have about 10 to 15 minutes at the end where we'll go through those. So please send any questions you have in. Okay, Minh, over to you.
All right, awesome. Okay, thank you, Graham, and thank you to Asiga for the invitation to speak today. It's such an honor and privilege to be able to speak for such a great company, and Asiga's been a great partner to collaborate with. I really believe in all your products and everything that you guys are doing over there in Sydney, so keep doing a great job. Today, of course, we're going to be talking about the return on investment of 3D printing with Asiga 3D printers. So a little bit about myself. My name is Minh Tran. I'm a second-generation dental technician. Been in the industry since 2006, where I've spent almost all of it behind a computer designing on 3Shape. I've been fortunate enough to be able to work with a wide variety of digital technology when it comes to the lab industry. And in my spare time, I run a blog called Dental Tech Tips, where we focus on the latest and greatest in dental technology. So if you'd like to find me online or via social media, you can find me in all the usual places by searching at Dental Tech Tips. So let's go over a brief summary of what we're going to try and cover today in the roughly hour or so that we have together. We're going to start with the initial capital investment and other cost considerations that you may have when purchasing an Asiga printer. We'll also look at the running costs, labor, as well as a cost analysis of outsourcing versus insourcing some of the indications that you're able to print with your Asiga printer. And of course, we're going to be diving in pretty deep into the ROI of each individual indication and exploring what's possible to print with your Asiga printer, along with the associated costs and benefits. Finally, there will be a 10 to 15 minute Q&A session where we can take a moment to chat about any questions that you may have, whether it's related to ROI or anything else in terms of 3D printing or digital dentistry as a whole. So let's get right down to business and define return on investment. Some of you may have much more business experience than I do, and you may already be familiar with all this or even more well-versed. But some of you in the audience today may not have a clue about calculating return on investment. So let's define this first so we can get into the details a little bit later, and just making sure that everybody here today is on the same page. Return on investment, better known as ROI, is a key performance indicator that's often used by businesses to determine profitability of a certain expenditure, in this case, 3D printers. ROI is exceptionally useful for measuring success over time and taking the guesswork out of making future business decisions. The ability to calculate return on an investment is extremely valuable for any business, regardless of the size or industry. After all, knowing if you're getting your money's worth is a basic concept that both individuals and businesses need to understand in order to strengthen rather than hinder their financial success. By calculating ROI, you can better understand how well your business is doing and which areas could use improvement to help you achieve your goals. At first glance, ROI calculation is relatively easy. Simply divide the gains from your investment by your investment's costs, and you have your answer as a percentage or ratio. If you calculate a positive number, you've gained a return on your investment. And if that number is negative, then you've lost money, unfortunately. For example, let's say you're a one-man dental lab that's decided to purchase a new Asiga Max to get into digital dentistry. So your ROI formula may look something like the financial gains after you've made that Asiga Max purchase minus the cost of the 3D printer divided by the initial cost of the 3D printer, which results in your return on investment. So this is a pretty straightforward formula that can be applied to practically anything. However, determining ROI can be a little bit more complex than this simple math equation that we see here. So when calculating ROI, it's important to take into consideration other factors that may be less obvious, such as time, hidden costs and fees, and even emotional factors such as stress. Before you can figure out the ROI of a 3D printer, you first need to calculate the total cost of ownership. These are all the costs that come with operating and maintaining that printer. And in fact, you should be doing this with both old and potential new equipment on a periodic basis. Factors that you should be considering include maintenance and downtime, replacement parts, how many employees are needed to operate equipment. All of these things can significantly impact your overall ROI. So let's go back to our 3D printer return on investment example. Your cost of your printer shouldn't just include the hard expense of the printer, but it can also include factors such as the time you spent exploring the different printer options, the time training for employees, other hidden costs like post-processing equipment that you absolutely need to produce restorations. And of course, being mindful of these factors, it'll really help you more accurately measure your return on any investment. Getting a clearer picture and understanding that everything is a variable that needs to be accounted for when figuring out your total cost of ownership, you might consider some of the factors listed on this slide here. If you want to request this slide or any other slide that you see from this presentation, just shoot me an email and I'm more than happy to provide you with any of the content that you see here today. But let's kind of go over some of these total cost of ownership factors. So prerequisite costs are not directly related to 3D printing in dental, but they are definitely necessary. So you do need a computer, which could cost $2,000, $3,000 US. CAD software varies, but I kind of pegged it at about $5,000 as an initial upfront purchase cost. And we'll kind of go over the ongoing costs of licensing fees later. You also need a 3D scanner or some way to get digital dental data in, right? So it's either a 3D desktop scanner that you purchase for $15,000, or if it's a dentist's intraoral scanner, then you need to be able to get through their portal. So there may be licensing costs associated with that. The, of course, biggest chunk is going to be the upfront capital costs. So for example, if you're buying an Asiga Max, you're going to be at about $11,000 US for just the printer. You do need a post-processing unit. Asiga does send a little UV curing box with it, but if you want certain indications, you may need a FDA approved or something that's been validated with your specific resin that you want to use. So a validated curing box could cost you $3,500. A washing unit, something like what I use is a Formlabs Form Wash. I think it's a very good one. That's about $500. They have other ones on the market like the Twin Tornado. Those ones run about $500-600 as well. Or you could also go with ultrasonic cleaners, which seem to work really great for a lot of people. We have one of those as our clean bath. Those run about $200. And then, of course, depending on who your reseller is, they may charge training and installation costs. So you have to think about those as well when purchasing and what that initial capital expenditure would be. Maintenance costs like calibration, downtime costs, replacement parts, repairs in warranty or out of warranty. So calibrating your printers, you need to calibrate pretty regularly. So that's would be pegged at whatever the labor rate. I put an average of about $15 an hour. Downtime costs, what I mean there is when your machine is down, it's not producing and it's not making money. So for example, if you print splints inside of your printer, you can fit, let's say, 4 splints inside of the build platform. It's going to take 4 hours. each splint you sell them for $150. So it's costing you $150 an hour when it's not printing. Replacement parts, that of course varies. If you break a lid, that's going to be a lot cheaper than a light engine, right? And then of course, if it's in warranty, it shouldn't cost you anything besides maybe the cost of shipping and maybe your own labor to replace it or to bring a service technician in. But if it's out of warranty, then you kind of have to weigh the costs and benefits of either getting a new printer or replacing or repairing the one that you currently have. The ongoing cost of ownership, this is a pretty big chunk, but these are kind of running costs. Nitrogen, glycerin, these are your inert environments. So if, again, on certain validated materials that need to go in the mouth, you need to have an inert environment in order to cure. A lot of the things that we use nitrogen just because I find it's a little bit cleaner than glycerin. But if glycerin is indicated, you can use that. It's a little bit cheaper as well. Isopropyl alcohol, most resins need to be washed with isopropyl alcohol. There are certain ones that need specific washing compounds. So depending on what that is, if you're using a lot of isopropyl alcohol, it may make sense to even look at a reclamation unit where you distill the alcohol, try and reclaim some. I know some units can be about $3,000. PPE and tools, of course, resins, they stink, they're messy, you need to wear gloves, you need to wear masks, you need to exhaust all the fumes and everything like that. So it's not a significant cost, but it is a cost associated with it. So over time, these things do add up. And of course, that running cost of CAD licensing, right? So you need to be able to produce these restorations and you need to pay the licensing fees to whatever CAD program you're using. If you're building models, there's typically a model builder fee. If you're making crowns or splints, then there's different modules that you'll need to pay for in order to be able to use those modules. For us, with the volume that we do, we're typically at about less than $1 per unit for most of our licensing. So it works out to, and the more that you do, that licensing cost gets absorbed and it becomes much less. Of course, when you get a new 3D printer, you may want to market it to your clients. You may want to educate your clients on some new product lines that you may be offering it. So for example, 3D printed splints, there is some cost associated with educating your clients. Maybe you want to put together a webinar, maybe you want to send out flyers, maybe you want to do a promotion. So there's costs there. There's also costs of marketing. So marketing these things. What we did as well is we ended up doing like a blind test with our customers where we had a traditional splint versus a digital fabricated splint. We sent both of them. And so you're doing double the work, but in the end, you're investing in hopefully getting your customers to convert over to digital. Of course, materials, this is the kind of the bread and butter of your printing. The resins, the costs vary, of course. It could be as little as $100, it could be as much as $600 for a bottle of resin. It just depends on the application and what company you're getting it from. And then, of course, the trays, you have various sizes and various applications. One thing that I do want to note here about the trays is, for example, if you're looking into printing little jobs of resins that you may not be using a lot of, it might make some more sense to kind of dedicate that to like a smaller printer like the Max that you can switch out these trays pretty often. Whereas if you're doing a lot of like a huge volume models, it might make sense to have a complementary bigger tray of like 5 liters for your Pro 4K. So that's how we kind of run our jobs. We have quite a few we have 2 Asiga Maxes, Pro 4K as well. And we run most of our models and splints inside the big Pro 4K, and then our little guides and various items, miscellaneous items, we run them in our Max printers. And then, of course, miscellaneous costs like labor, I put that at about $15 an hour. Of course, that's the cost of building models, nesting these models in, cleaning things, nesting all these different parts, post-processing, all that stuff. So you have to kind of figure out how much time it takes to do all that. And then, of course, electricity. These printers, they're very energy efficient, so they don't take up much, but that is a cost over the lifetime of these printers. And then, of course, with isopropyl alcohol and all these other things, depending on your jurisdiction, you're probably going to have some kind of hazardous waste disposal costs. So another thing to kind of factor in. And also one of the reasons why maybe you should look into some kind of distilling or reclamation for your washing solutions. And then at the bottom here, I have the revenue streams. These revenue streams are things that will make you money, right? So direct print applications is where you start making money with your printer. Final restorations, we don't have many resin options at the moment, but that again is somewhere that a revenue stream for your printer. And then of course, if you feel confident enough, if you have excess downtime to kind of offset that, you can provide outsourcing to others, right? So using that downtime on your machine to print some models or print whatever else to other labs or anybody else, or even just offering 3D printing services locally for whatever parts, right? These things will print anything that you want them to. So now that we have a better picture of what the number for the total cost of ownership is, you can determine what an ideal payback period is. So a payback period, it helps determine what's affordable. So this is just the cost of the purchased equipment divided by the amount of profit it's creating. So in the example above, this would be roughly $16,000 divided by an estimated $5,500 of profit per year, would equal about 3 years before the equipment has paid for itself and the lab has broken even on this investment. All the years after that, where you own this printer and it's running, would be pure profit for the lab. And so keep in mind, this is an extremely conservative estimate. I just threw out $5,500 as a nice round number, and 3 years as kind of a digestible understanding. But we'll go into more realistic numbers a bit later on in the presentation. A normal payback period for most equipment, when I kind of look at it, and in general, used to be 5 years. But in today's increased market for increased competition for capital, and they're forcing expected payback periods, especially if you're looking at lending, sometimes to be as short as 2 years. While there are several different cost justification methods that you can use, like internal rate of return, net present value, all these other financial terms I'm not going to bore you with, all of them focus on reduced labor, reduced inventory, or a reduction in the operating costs. But how do you justify buying a machine that doesn't necessarily lower costs, yet it's critical to your lab's long-term survival? So let's get something very clear. Good 3D printing, and I'm going to emphasize the word good, good 3D printing is expensive. And 3D printing in dental is very expensive. But good 3D printing is absolutely critical to your dental lab's survival. So when we're talking about additive manufacturing in the dental space, what we're dealing with is mass customized medical devices. So 3D printing in dentistry is kind of like a perfect marriage between the two, because it allows us to produce these mass customized devices at scale. So of course, there's other factors that, other than just purely financial reasons for going into a purchase decision. So is your old 3D printer that you may have not producing accurate enough results anymore, and it just absolutely needs to be replaced? Has your manufacturing process changed and your old traditional lab equipment just doesn't operate how you need it to anymore? Do you have retiring employees who you're having trouble finding suitable replacements for? So, or maybe you're just ready to pull the trigger and start going digital. Rather than measuring returns solely on the capacity and their cost effectiveness, factors such as competitiveness, utilizing better technologies, and improved methods are all factors that are being used to determine overall returns that a new piece of equipment could provide. And it doesn't matter if you're a small one-man lab, a mid-sized lab, or a multinational lab group. Practically every business decision requires knowledge of ROI. If you're not sure whether your efforts are yielding results, how can you properly optimize profitability? You really need to understand the importance of ROI is crucial for any business to succeed, and not only in printing, but across the board in business in general. So now that we know what ROI is, let's get the biggest and most awkward question out of the way. How much do these printers cost? Well, the most popular model, the Max UV, comes in at an MSRP of $10,990 USD, and the Pro 4K80 comes in at an MSRP of $24,990 USD. And these prices are approximate, and again, they will definitely vary based on your reseller, freight costs, location, import duties, currency conversion, along with all the other variety of factors that we discussed amounting to the total cost of ownership. So these retail suggested prices are fine. It tells you that the Max is X amount of dollars and that the Pro is Y amount of dollars. But it isn't really telling you much, to be honest. Comparing one printer to another based on its sticker price alone really doesn't tell you anything important. And it's an even less useful metric when comparing different brands of models of printers against one another. The metric that I always like to use when measuring the value proposition of one 3D printer versus another when it comes to cost analysis is the cost per millimeter square of build area. So what are we talking about when we use this metric? Well, you take the entire upfront purchase price of the printer, and then you take its XY area or its build envelope, and you divide those two values. The number that it spits out at the end is the cost per square millimeter. And this value really levels the playing field and paints a much clearer picture of how much value you're getting, and it gives you a much better apples to apples comparison when looking at printer prices. So for this chart here, you can look at the column you want to focus on is this millimeters square here. And the lower you go down on the list, the better you are in terms of overall cost when compared to your build envelope. Of course, this one factor doesn't tell you everything. Once you drop below a certain threshold on this list, you're in the range of budget printers that simply just don't cut it, in my opinion, for scalable dental printing applications. But you also need to look at a few other factors like the light engine technology that's powering these printers, as well as the materials library if they're open or closed. So for example, if you have an MSLA printer that has a large build platform, MSLA is a much cheaper light engine technology. It won't give you ideal results. Those pixels are always square and they can't be scaled down the same way as a DLP projector can. But I digress. The other metric that you really need to look at when comparing one printer to another is the speed and accuracy. So speed is only one side of the equation. You can have a really fast printer, but if it lacks accuracy and precision, then you're ultimately not going to get good results. And if you have you can also have a very accurate printer, but if it's not able to produce models or any other parts in a timely manner, then you won't be able to get these results efficiently. These numbers here are from an independent test that I participated in, and it was conducted with a straight-out-of-the-box Pro 4K. More specifically, this was the Pro 4K from our lab that was barely even a week old. So anecdotally, our results are likely more accurate now since we've had more time and experience with the printer, and we've tweaked these settings a bit since then to be even more accurate and precise. So if you look at this chart here, you can see that the Asiga Pro 4K, there's a little note there that says that it has a variable Z option. So what I'm talking about there is the multi-range. So with a regular 50 micron layer thickness, you get an hour and 45 minutes of print time for an identical build job compared to some of the other results. But when you use multi-range, so if you do 100 micron layer thickness for low detail areas of the model, and then you switch to a 50 micron range for the remaining dentition part of it, that can lower your print times down to 55 minutes. So this sets the Pro 4K ahead of even the fastest non-contact DLP printers. And it's a very innovative way of speeding up the printing process. So let's switch gears a bit and look at the ROI of outsourcing versus insourcing your 3D printing. So for example, if you're a smaller lab or even a bit conservative with how you want to dip your toes into 3D printing, just to get your feet wet, maybe outsourcing is the way that you want to get started with 3D printing. And this is an excellent way to do that with little to no upfront investment. There's plenty of companies who specialize in outsourcing, and they can be excellent partners for you. So when we started with digital models way back in 2009 at our lab, there was no real open platform or outsourcing centers that you could send 3D models to for printing. So when we first became an ITERO certified lab, the only real option was to outsource your model to ITERO. So ITERO models, they're milled models, and to this day, ITERO still produces milled models when you choose them as your outsourcing partner. Of course, things have progressed quite a bit since then. So there are, of course, plenty of companies that you can choose from to outsource your printed models to. The caveat here, of course, is on a single order basis, outsourced models are expensive. But of course, that makes sense because these companies need to make a profit when offering these services. Otherwise, why would they do it, right? And there's nothing wrong with that. Like, what I like to do when I'm diving into something new is I'll try to partner with Core 3D or an Argon or a Whip Mix that's got those dollars to absorb all that R&D required to create the standard operating procedures, and in order to produce these new digital products, right? So what this allows me to do is that I can tweak my own internal processes and monitor what my cost per item is, and find that critical inflection point where that payback period and the initial that total cost of ownership, where I can at least break even by bringing that stuff in-house for myself and having it make sense within that given payback period. The goal for me with any digital technology personally, and this is not what I'm saying everyone should do, but is for whenever I'm getting into a new product or a new workflow, the goal for me is always to find out how quickly and when I can bring a technology in-house. And the reason for that, of course, is just for better control, reduce overall costs, and just general higher efficiency. You can get these things turned around a lot quicker if it's in your own building rather than, somewhere across the country. So the example I use, of course, is crown and bridge models. If you're sending to Itero for milled models, your cost is roughly $30 a set with shipping. If you're using a printing service like the one from Whipmix, then you're at $32 for a full arch set, or about $16 for a set of quad models. I just wanted to say thank you to Sherry Weatherby for sharing this ROI calculator for me to use in this presentation. I just wanted to give her a little shout out for that. These numbers make sense on a small scale. So again, what you'll see very quickly, though, is once you reach a certain point with outsourcing, it just makes sense to bring these products in-house if you're able to. So let's say you've got an Asiga Max, you're looking at it and you're considering buying, and currently you're outsourcing 50 cases, which is an upper and a lower, right? So you got about 100 models per month that need to be printed at an outsourcing center. And then you can find with this calculator very easily that the break even, that is pretty much the break even point. And keep in mind, 50 cases is not a whole lot of work. That's an average of 2 to 3 cases a day over a 20 working day period in a month. So if you're doing 2 to 3 cases a day of digital models and you're currently outsourcing, it might make sense to just bring that stuff in-house because your cost difference of outsourcing versus insourcing is negligible or zero. Once you start adding things like surgical guides, splints, and all these other direct print indications that we'll be exploring a little bit more in a moment, you'll quickly see how in-house printing can really generate a return on investment in no time because these products then start actually making you money as well. So let's take a look at these indications and break them all down by the numbers. We've already been talking about 3D printed models, so let's just carry on with that one there. Much like their traditional gypsum counterparts, 3D printed models are typically relegated to an entry-level position, and the economics and practicality of model fabrication make that a necessity. The reality is that models need to be fabricated as cheaply as possible because in the end, they're ultimately a disposable item. But this shouldn't be confused with the myth that models are not important. One of the first things that I learned in the lab, I was fortunate enough to learn, was that a properly fabricated model is an integral part of the process as a whole. It's the foundation that you kind of build everything else on top of, right? So models are used to check and verify margins, check fit, contacts, occlusion, and a properly constructed model will be an accurate representation of what exists in a patient's mouth. At our lab, we try to cater the fit of each individual case to a dentist's specific preferences. So if a dentist prefers a heavier contact or a slightly lighter occlusion, we're able to control that on the fit of the physical model. And it's not an exact science, but there's an intuitive feel that you get from working on a model with your hands that you don't achieve from dialed in numbers on a CAD program. These are some of the non-financial factors that we had discussed earlier. From a purely financial standpoint, printing models is always going to be a negative ROI item. But so is your entire model department as it is right now, if we use that rationale, right? The return on investment really comes, when it comes to models, is how precise and accurate these models can be in order to facilitate better work and further down the line on all the devices and restorations that you'll be producing on top of these models. 3D printed models can be used for crown and bridge work. For our lab, this is probably the most popular thing we use for 3D printing. You can also 3D print models to be used in removables fabrications such as splints, night guards, retainers, ortho appliances, etc. This is an excellent growth area for 3D printing. I find that most traditional models for removables are usually poured using an alginate or some other cheap or inaccurate impression material. So 3D printed models are equally as accurate across the board, whether it's for crowns or for an Essex splint. So the feedback I've found from my dentists has always been that they've been very positive for the improved fit, especially for our removables restorations. Diagnostic models and treatment planning is another popular use for 3D printed models in our lab. Rather than traditionally hand waxing a case to do a mock-up, you can do it digitally and then print those models. So there's many benefits to this, of course. The first is speed. You can mock up a case with perfect proportions using a 3Shape Smile library in a fraction of the time that it would take you to hand wax the case. The 3D models then, of course, can be subsequently printed while you're doing something else, and then you can fabricate like a suck-down thermoform or like a silicone matrix that you can then send to the doctor. So diagnostic models are also nice because they're actually one of the few rare items, model items that you're able to charge for at the lab. So typically in the past, there was an associated diagnostic fee per unit that we've always charged for hand waxing. So we haven't changed that fee, and that actually helps us to offset the cost of these printed diagnostic models. It is also possible to fabricate implant models digitally as well, digital analogs and soft gingival material using the analogs. So we also produce digital ortho models for records, which produces perfect models every single time. You don't need to soap them or polish them. So you get all the nice aesthetics of an orthodontic study model without the associated labor or the skill set that's required. The most popular application for digitally printed parts in the world by far is the fabrication of clear aligners. And a lot of the pioneering in dental 3D printing can be credited to one company, and that, of course, is Invisalign. They're really like one of the first companies to really go out there and use this technology on like a mass scale, where they first started in 1997, and they'd work on these traditional stone models, and they'd segment the tooth, move the tooth a little bit, duplicate the model, and then they'd segment the tooth, move it, duplicate the model, and go on and on and on. So on average, for an average Invisalign case for comprehensive orthodontic treatment, you're doing anywhere from an average of 40 models. So to this day, Invisalign is the largest producer of 3D printed parts. So I'm not just talking about 3D printed dental parts, but 3D printed parts in the whole world. And on any given day, they're printing probably about 325,000 models per day. So you can just imagine the scope and scale of what they're doing. In our lab, we provide a clear aligner solution. We use a design service called Full Contour, where we send it. They do all the orthodontic treatment planning. And then once we get the green light and approval from the dentist, we get those models, produce them in-house, use some suck-down thermoforms, and we make those aligners. And we charge a significantly lower price than Invisalign. And some of our dentists have expressed that they're really happy of having an alternative budget option that helps for relapse cases and little cases that they don't want to commit to like a full Invisalign treatment for, right? So since we're on the subject of ortho models for records that we were just talking about, and of course clear aligners, we can also produce a very good, cool application is indirect bonding trays. So indirect bonding trays is very interesting because it's, like I said, a direct print application. But depending on the laws of your specific jurisdiction, if the orthodontist legally has to be the one to be placing the brackets on the patient, what an indirect bonding tray does is it speeds up an appointment where you could have all these preset. They come in, they just put it in 30 seconds, and that all the brackets are placed, versus booking an hour chair time where they have to manually place all these brackets. So another direct print ortho application, of course, is clear aligners. These things are still very much in their infancy because of the brittleness and the absorption rate of these clear aligner trays. And of course, the same thing goes for 3D printed ortho retainers and all those different appliances. Those materials are very much in their infancy, and there's very little data on their availability and long-term viability at the moment. But I thought it was important to mention those for the sake of completeness for 3D printed orthodontics specifically. So keep in mind that we're talking about direct print applications, not the suck down clear thermoforms that you do on models. In terms of ROI, again, models, ortho models, clear aligner models, those are loss leaders that eventually just get tossed in the trash, right? Once we get more reliable direct print applications, the sooner we can start generating better returns, like the indirect bonding tray example. Speaking of direct print applications, one of my absolute favorite applications that actually makes us a lot of money in the lab with our 3D printer is, of course, 3D printed splints. So what I'm going to do is I'm going to play a little video clip that's an excerpt from one of my previous splint courses that I taught, where it does a really good job of explaining part of my workflow as well as some of my rationale of how we save money and get a more efficient workflow out of 3D printed splints versus traditional ones. So sit back and enjoy, and this gives me an opportunity to drink some water. Face bow or something like that, but I mean, who gets a face bow for a full mouth reconstruction, let alone for a splint, right? So the majority of splints traditionally that we would be working on, you get some kind of bite registration, you'd put it on there, and then it would be mounted on a simple hinge articulator. So number one, not having centrifugation wasn't ideal back in the day. Number two, having it mounted on a hinge articulator was not ideal either. And we'll get into this in the next slide here. So when I initially started this whole process with 3D printed splints, I really didn't think of the articulator as a very critical point. And I did mention this in a lot of my previous courses that I put on, but I've really expanded this portion of it because we found that this is a very, very critical portion that is ignored by a lot of people. And I know I've helped a lot of you as well, one-on-one on some kind of training there where simple hinge articulators just don't translate that posterior opening ratio properly, right? So you can see here, I'm not sure if you can see the mouse, but that the arc of closure between the full size articulator versus the hinge are completely different, right? So appliances created on these simple hinges usually result in splints where even though it has proper relation on the articulator, you spent 15 minutes smacking the thing and making all these marks and grinding it all in, the bite in the posterior is typically very heavy, and the contacts in the anterior are going to be light or open when you actually deliver it to the dentist. So then, of course, the dentist has it in the mouth, and then they're spending chair time grinding and fitting the bite. So leaving the distal areas very thin, very compromised, and then eventually they get a bite, right? With 3Shape Dental System, every case is virtually mounted on a semi-adjustable articulator, like a full-size one that translates that 110 millimeter condylar, intracondylar distance. And the results from this virtual articulation and opening of the bite to the closer to the actual arc of opening of the patient means that you have reduced chair time for your dentist. You also have increased patient comfort, better compliance, and ultimately relief and less wear for the patient, right? So we've probably done hundreds, if not thousands of these splints by now. And the thinness of the material, the thermoplastic qualities, the durability, even with extremely thin designs, patients absolutely love them, dentists love them, and even our technicians love working on them and producing them because they're just so efficient, right? Going back again to this figure here, I got an alternate figure here. Please pay particular attention to these two arc of closure. You can see this one here is the smaller articulator and the larger articulator. So you can see this green one here where the opening is of a typical hinge articulator, where if you open it on the larger articulator, the arc of opening will be much more rapid and much more steep. So I've gotten in heated arguments with people. I've scratched my head multiple times when we started doing this in the beginning. I butted heads with my removables department head because the articulator that you use to verify the occlusal contacts is absolutely critical and not so critical. We'll cover that in a second. So if you're designing on a virtual full-size articulator and then you're mounting it onto a small hinge, your occlusion is never going to match. Okay, so like I said, we've done thousands of these by this point, and we get them from the printer, and then the people in the removables department would put it on there, they'd mount the cases, and then they'd argue with me because their articulators, they'd spend twice as much time grinding in the contacts and complain to me that I'm designing them wrong or one of our designers wasn't doing it properly, right? So finally, I made an executive decision. I said, hey, you know what? We're going to print two of each one, okay? I'm going to have you guys adjust one on the articulator, and then the one that's printed, I'm just going to remove the supports, polish it, and we're going to send both of these out to the offices. And we did this probably for about a period of a month. And the feedback every time was that the polished ones that we got back straight from the printer was the ones that the dentist ended up putting in with 0 adjustments. So I know as dental technicians, we typically want to have this hands-on experience where you verify on the model and you make sure that you feel good about it. But with digital, you have to have kind of like a bit of like a leap of faith almost, and trust that your designs are correct and not the other way around. It's very counterintuitive, especially because the profession is so hands-on, but we've switched over almost all of our clients to these printed splints. And I actually only have one guy who tried it and didn't like it, but he's an older guy was overdue for retirement probably 30 years ago, and technology is just weird and scary to him. But yeah, trusting that your design on the virtual articulator, I know it's a little bit funky and counterintuitive, but it really does work. We've done thousands of these where you just take them out of the printer, take off the supports, polish them, and off you go. And it's been super, super, super efficient. So now let's move on to my face bow. All right, so yeah, when it comes to 3D printed splints, we no longer even bother with printing an opposing model to check occlusion. We just remove supports, polish, and we just deliver it. So it saves us a ton of labor time and a boatload in waste compared to our traditionally made Thermoflex appliances. Then, of course, the designs can be modified and adjusted to create deprogrammers, sleep apnea appliances, and a whole variety of different direct print applications that you can actually charge a profit for. So the ROI on these, especially the soft splints, have been phenomenal for our lab and one of the most profitable items in the lab in general. Guided applications, surgical guides, perio guides, prep guides, verification jigs. Guided surgery is huge with the advent of digital, and especially with 3D printing. So you have your surface scan from either a desktop or intraoral scanner, and then you have your cone beam CT scan. You merge these in Implant Studio or whatever planning software that you use. And once you have that plan, you're planning this from the top down rather than the bottom up. You create an ideal crown. You can plan for tissue sculpting. You can have a better emergence, better access hole that's kind of dead center. And all these things, you can kind of package them up as like a one package implant price. With the planning, you can avoid major nerves. It makes everything extremely, extremely predictable. Then, of course, once you do that, you produce a guide using clear resin, something like Free Print Clear or some of the other. What was the other one that I was using? No, for guides, actually, I use either VeriGuide or Key Guide from Keystone, and VeriGuide from Whipmix. Yeah, so we use both of those. Those could be autoclaved just fine. Then you order the little sleeves from Nobel or Stecco or whatever company that provides the implant sleeves. And then you can also deliver it again with a temporary shell that you fabricate for good emergence. Send that to the doctor. If they're doing an immediate load type case, once everything's healed up, fully integrated, you just take your old design file, verify everything's good, rescan it, and then you're doing little to no work on the redesign because you've done all the work up front. Perio guides, of course, they're a breeze. That's where you're doing some crown lengthening or any type of soft tissue augmentation. Same thing goes for prep guides, right? So these tools are being planned from the top down rather than the bottom up. And we're visualizing what these final restorations will look like using CAD software and planning for these and printing these guides that help to achieve more predictable outcomes. So another benefit, of course, of 3D printing and all this, especially with the Asiga printers, is it provides you with more predictability, less chair time, less adjustments. So it saves you on the later steps, right? So one of the most interesting things we've been doing lately with these printers is we'll be printing verification jigs, right? So a Tryin bar. So if you're doing like a full bar, rather than milling a PMMA bar or milling your titanium without a verification, even if you mill a PMMA, it's very time consuming and ties up your milling machine that could be making you money milling crowns or something like that. With 3D printing, we can print something like 6 or 8 bars that we've designed all at the same time. And it takes 30, 45 minutes at most for those try-ins. So it's a huge time saver, number one. And the other thing is when you're milling PMMA, it actually has a lot of burr deflection, so it's not very accurate compared to a printed bar. So the printed bars are much more accurate for verification purposes, especially if you're doing direct to multi-unit, which has a built-in amount of play for passivity, right? So my cost with for the multi-unit abutments is less than $5 per arch plus the cost of the titanium base. If you're doing direct to MUA, then it's just $5 for that little verification. And of course, the returns on these are excellent because you can send 10 of these. So let's say it doesn't fit. You go back, you can print 10 of these, it'll cost you $50. That's not a lot of money. If you decide to forego the try-in, however, and you just go, okay, well, I'm going to deliver it right at finish, and you build them for $7,000 and it doesn't fit, guess what? That's an expensive mistake. So I'd much rather print 10 verification jigs, go back and forth with that for $50 rather than having to redo a $7,000 full arch. So along the same lines as verification jigs for implants, we also print quite a few different Tryin materials for verification on larger and more complex cases, right? So things like monoblock denture Tryins, these are particularly nice because you can send a patient home for the weekend with a monoblock and they can really live with it, get their opinion from friends and family members, and really see how they like test driving that new set of dentures, right? We also do try-ins for long spans, for full mouth cases, things like that. And that way the dentist has a provisional material that they can adjust and grind and play with the lip line and the cant lines and everything like that. And once they send it back or they scan it and they send it back to you, then you have a guide to kind of work off of. So in terms of provisionals, I prefer to print my provisionals if they're not meant for long term, right? So because number one, the fit again is so much better than milled PMMA. When you're milling PMMA, like I was saying, you get that burr deflection where plastic and I always end up with about 40 microns of excess PMMA that I always have to grind and fit. So it's quite a bit of labor. And then we either have to dial up our cement space or bring our burr compensations way up to kind of make up for that difference. And it's always suboptimal when comparing a milled PMMA versus the anatomical detail of a printed provisional. Of course, you can also design and print custom trays in a matter of minutes while that printer's busy, you're off doing much more important things rather than trying to sculpt a handle using some rolled up sheets of triad. These amounts for these try-ins are so insignificant. You're literally talking about 25 cents per unit, right? Oftentimes less. So what I'll actually do is a lot of the times for provisionals is I'll end up printing up 2 sets of these provisionals because they end up costing me nothing. Throw the second set in the case pan. I can send it to the doctor's office or we keep it at the lab. And if there's a failure of the temp, like, oh, the temp broke or whatever, they call us, we can say, oh yeah, no problem. I'll go over to the lathe, polish it up, send it, and they'll have it at the office in an hour rather than saying, oh, well, can you rush the crown or something like that? So that's been a huge time saver. It costs us almost nothing to print 2 sets. So we just do that and it's been awesome. And of course, one of the first applications that we do for 3D printing, also another one that I always kind of print 2 sets for, is for patterns for castable applications, right? So casting, pressing. These are super cost effective. The resins are very precise and highly efficient, especially if you have enough volume for it to make sense. So what we particularly like is printing and pressing for veneers. Because margin fidelity, overall fit of the veneer, and some of the fine, like if you're doing paracomata and like some kind of craze lines or anything like that, you get really good reproduction of that detail with the printer, believe it or not. And the fit is so much better than a milled Emax crown or a milled wax pattern. One trick that I actually use is I don't even bother ordering castable resins at the lab. We don't keep any of that on hand. What we just do is we throw all of our castable and pressable patterns into our Asiga dental model builds. So whenever we have any blank space somewhere we're doing veneers, we'll just throw it into a dental model job. So then what we'll do is we'll invest in burn out the Asiga dental model at 915 Celsius for 1 hour. And then the results have been absolutely flawless every time. from a monetary perspective, you're also saving a ton of money when compared to milling Emacs CAD, right? So for a single block of Emacs CAD, you're in it for about $30 a block. And that block will yield you 1 unit, maybe 2 if you're lucky and you have 2 lower central incisors or lateral incisors. You can squeeze maybe 2 in there. But even then, the fit isn't great. You're compensating for huge burrs that you need for grinding that glass. With printing and pressing, you can get an Emacs press ingot for $15, and then you get 4 units for a single pressing ring. The margins are better. The pressed Emacs is actually stronger than milled Emacs, and of course, you're getting under $5 per unit when printing and pressing versus $30 when you're milling. Digital dentures is still very much in their infancy. In my opinion, it's the most reliable way to still produce digital dentures today is to mill the denture bases and then either fit pre-made or milled teeth to bond into those sockets. Of course, this is time consuming and expensive, and you're tying up your $100,000 mill for the same amount of time that you probably could have milled about 30 crowns. So I'll let you guys do the math for that. 3D printing of denture bases is currently limited by the resins, and the most common resins have the strength of an economy denture at best. So there are some promising resins from Dentsply and EnvisionTech that are going to be locked and closed to their specific printers for the foreseeable future due to exclusivity and licensing. So it's a real shame in my opinion, but we're definitely at the forefront of and the pioneering stages of printed digital dentures. So there's plenty of room to grow, and it's only a matter of time before somebody lightens up a bit and releases a high impact rated denture based resin that's open and can compete with those closed options. In terms of time savings, reduced labor, reduced material waste, better consistency, and reproducibility, digital dentures is an extremely attractive option when you look at all of those types of savings, right? A lot of R&D dollars are going into and being poured into this segment. So I really see a lot of progress over the next couple of years for the denture market. Partial denture frameworks are another very exciting workflow where time savings and efficiencies can be realized. No more duplicating models and waiting, no more refractory casts, no more clunky surveyors. Again, you can scan in your model, the undercuts are automatically blocked out, and you go ahead, design your partial. Typically, if you would want to either send this out somewhere for some kind of SLM, or you can print your patterns in your Asiga printers and then have those cast in-house, send them off to be cast somewhere. A really neat one that I actually like to do is I'll print my partial denture frames in like a Tryin material, like DentaTri, and we'll send that to the office for them to try it in. If the fit's good, or if they need to adjust anything, they can adjust it on there. We'll duplicate that. And then we'll actually duplicate that in a metal-free material like acetal or Juvora or whatever other materials that are rated for use as partial denture frameworks. So then using the Asiga Max for something like that really augments that workflow very well. So rather than going through the expense of casting or laser melting or getting a $25,000 Bago Nautilus that you can buy, a Pro 4K for, you can get a Pro 4K, print models, and at the same time get your partial frameworks and mill those out in acetal or something like that. So as you can see, 3D printing with the Asiga printers has you covered for pretty much every indication imaginable with excellent return on your investment. So the more that you focus on direct prints applications, you'll realize a return much quicker. Doing models in-house versus outsourcing, you're going to realize a lot more savings and a lot more control. So with continued R&D and the market trending towards more additive manufacturing solutions for dental, choosing an open solution provider like Asiga really guarantees that you're going to get the best return on your investment for the long run, and you're going to get support for materials, again, for the lifetime of your printer and beyond. So with that, I'd like to say thank you to Graham and the whole team at Asiga and everyone who joined today in the audience to listen to this webinar. Hopefully you've picked up some valuable information that'll help you in your purchase decision moving forward. I'm more than happy to take any questions that may have come in.
That's great. Thanks, Min. I'll just bring up some questions for you now.
For sure.
Where are they? So what you touched on your that you have you've got an alternative Invisalign process that you use. Which software do you use for that?
So what we do actually is we use Full Contour as a partner. So they're a subsidiary of 3Shape. They're a design center. So we just send the models there. They do all the ortho planning. So what's really attractive about this is the planning fee, I think, is like $100 US, $99 US. You can send it to the dentist. They sign off on it. They approve the treatment plan. Then you download those models, take those models, throw them in your printer, and then off you go.
So they provide you, they basically give you a summary as to what the treatment plan looks like.
Yeah, exactly. If their 3Shape does have Ortho Analyzer, and they also have, Ortho Analyzer would be the one that you're using. I just don't have very much ortho experience, so I don't feel very comfortable, but it is a very attractive option because you're also able to overlay CBCT data. So you can visualize centric root position, different things like that. So you can really plan in a very predictable way for maximum kind of movement of teeth where you stimulate the bone and generate enough bone growth, right? So it's really neat how they have the software. That's the software, of course, that Full Contour uses, and they have experienced orthodontists on staff that do all the planning. So it's not just some random guy. These are actually trained doctors that do all this. So we rely on that. It's a very cost-effective option. I try not to do more than 8 trays because at that point you're kind of moving into Invisalign territory, which doctors will prefer. So it's a great way for us to just kind of offer a little value-added product offering.
Yeah, and I think that's an interesting point as well, that this is a service that you send your data out to, and they do all the planning and the design for. There are other companies that do that, aren't there?
Yes,
and
of course.
for different dental indications as well. So it just allows you, having a printer in house, you can still sub out some of that design work and
absolutely.
Still print in house.
Yeah, exactly. Like I was saying for the outsourcing versus insourcing, right? Like if you don't have the capability, if you don't have it, there's nothing wrong with outsourcing to kind of ramp up your own processes, right? Because we don't know everything. And a lot of these companies, they've done the R&D, they've done the legwork. So leaning on them as a partner until you can bring these processes in-house, and you're leaning on, let's say, an Asiga Max, that's an excellent way to offer digital products that you may not otherwise be able to do.
Yeah. It's good. It's good to know. Of all the dental appliances that you make, what is the most profitable? So which is your favorite?
So Key Splint Soft is what I'd say is the most profitable that we use. And so like I said, it costs us probably less than $10 to produce it, and we're charging about $150 US. So that's quite a good profit margin, and there's like I demonstrated earlier, there's very little to it. You're not producing an opposing model. And even most times we don't need the working model, but we do because we like to check the fit and the retention of it. But you can go completely modelless on that, and then you're even cheaper. So
is that $10 for printing is material? Is that
so that's the cost of. So yeah, that's the cost of the material, the curing, a little, and we factor in like the kind of the amortization of the printer over how many units we do, right? Because we've done, I'd probably say conservatively 2,000 of those over the period that I've had Asiga Max printers, right? So it's been great.
And that material after printing is basically wash, support removal, cure, and then polish.
Polish, yeah, and you just follow their polishing protocol, and they come out gorgeous.
Yeah. Okay. Cool. With the materials that you use, do you switch materials on the printers, or do you have them dedicated to a particular material? Do you regularly switch?
So what we do is we have the Pro 4K. That Pro 4K is almost exclusively 99% of the time Dentamodel. If we have a big batch of Key Splint, we have a 2-liter tray of Key Splint that we use for that, right? But the one Max, we pretty much keep just for Key Splint. because we have so many of those. And then, of course, the other one is kind of our variable one. So if you have a rush model that comes in, or a diagnostic, or if you have surgical guides or anything like that, we'll kind of do it on that. Any temporaries, provisionals, but we'll kind of swap between the two little maxes. I'm actually due to buy another one because we're just the demand for printing is so high. So we're debating between another Pro versus another max. So
yeah, great. Well, that sort of comes to a question that I have for you. Is when would you recommend a max UV over a Pro 4K or vice versa? So I know you're saying that you're looking at maybe a third max or a Pro 4K. Asiga, we don't like push our higher costing system on anybody. It's really down to that company's workflow and how they've set up that workflow for themselves. But when would you, in your words, when would you recommend a max UV over a Pro 4K or the other way around?
So the max, I find, so the analogy I'd probably say is actually if you look at the sports car versus a truck, right? They both do very different things and they have their uses, right? So the Pro 4K is very good at large volume. So if you have a large volume models, a large volume of splints, that's where you want your construction truck to come in, right? If you want an agile, nimble printer that you can switch up materials, you're not sitting on huge trays that you need to fill up with material, hold more inventory. You want it agile, you want it flexible, you switch it out more often. A max is probably better for you. That's the sports car.
Yeah. Okay. Good. Well, that's great. I think that we're 2 minutes over, so that's pretty good. I'm pretty impressed there. We've been known to go on a lot longer than that, and there's no other questions coming in. So I think we can close this off. So Min,
fantastic.
Thank you so much again for your time today. And for anybody that has any questions for Min, please send them through to him via his email address, which you showed just previously. What we can do is we can update the posts on social media so that, maybe Min, you can just put a post up on there. Absolutely. Or a comment with your contact details. For anybody looking to keep up to date with Asiga's news and activities, you can follow us on all of these social media channels or join our newsletter. Again, thank you so much for your time today, for watching this webinar. Min, again, thank you so much. That was really great, and we'll look forward to the next one.
Awesome. Thank you so much, guys.
All right. Thanks.